let's fill in some gaps and then answer some questions, make sure that everything is clear. So data describes its characteristics. Of individuals. And remember, the individuals can be people, can be rabbits, can be pencils, can be anything. And it can be normally either numeric or non-numeric. Like examples of non-numeric you gave me already, the eye color, gender, of the non-numeric. And the numeric, weight, height, temperature, blood pressure, all these are numeric. Non-numeric, again, gender, eye color, hair color. What is the entire group to be studied called? The entire group. The population, very good. The entire group of individuals, whatever the individuals may be, it's called the population. Very good. What do we call a person or object that is a member of the population?
Sample.
Careful. So how do we call a person or object? A person or object of the population is called? Individual. Don't be afraid to speak, please. When you answer, even if your answer is not right on the money, it helps me realize what I maybe skipped or forgot to say, or maybe it's not clear. So please don't ever be refrain yourself from answering. Give the definition of a sample. In short, a subgroup or a subset of the population to be studied. So we want to study a population, we determine a sample, and what is that? A subset of the population. What do we call a numerical summary of a sample? I didn't mention that, so now is the time. It's called a statistic. So coming back for a moment, when we talk, I'll go back in a second. For a sample, we are collecting a sample to study and draw conclusions about the population. So we only have a small subset of the population. We are trying to make sure, first of all, that this is a representative, a good sample, representative of the population, because we want to make conclusions about the whole thing, the whole population. So whenever we collect data from a sample and we obtain, for example, let's say the mean, that will be denoted by X bar. We're going to talk about it when time comes. This is a statistic. What do we want to conclude? That the mean of the population, which will have a totally different notation, is the Greek letter mu. Mu. It's a U with a long tail. First one. What do we call a numerical summary of the population? Well, that is called a parameter. So like any class has its vocabulary. So these are our key words. So numeric, non-numeric, population, individual, subset, sample, a subset of the population, a statistic, and a parameter. When we talk about the statistic, we talk about a sample. When we talk about parameter, we are talking about a population. So we will be using a statistic later on in the semester, a statistic to predict or make conclusions about the population mean, which is the parameter, that we cannot determine. It's too expensive, too time consuming. We can't determine. Sorry about that. We cannot determine this. But we collect a sample. We're going to use the statistic to predict the population parameter, which is the mean. Give the definition of descriptive statistics. We know that descriptive statistics, we collect data, we summarize, analyze. Give a definition of inferential statistics. Predict from a statistic the parameter. When we say we make an inference, we say we predict, we draw a conclusion from the statistic about the parameter. Are you with me, everyone? My grandma used to say that if you want to just crush somebody's heart, just ignore him or her. So please don't ignore me.
I caught up.
Okay, good, thank you.
But I'm like, did she see my thumb? Did she not see my thumb? I'm like, what do I do?
Everything okay? Are you with me, everyone?
I'm caught up. My pen ink isn't.
Okay. Do you want me to? Why don't you? But I really want you to stop me. That's the whole thing. So, for example, Winston has disappeared. Ramona is not there. So I don't know. Am I losing anyone? I hope not.
I'm still here. I'm just writing.
Okay. So.
Professor,
I'm right
Okay. Good. So.
can I ask you?
Yes. Anytime.
There are landscapers outside, and I have my slider open. I need to go close the
Of
slider.
course,
Can I do
please
that
do.
real quick?
Yes. Just for you. If anyone else would have asked, I would have said no. I'm kidding. Of course. Of course. If you need to go to the bathroom, or I'm just hoping that you're paying attention. Okay. Is this statement an example of descriptive or inferential? Circle the correct answer. The percent of students in the survey who would return the money to the owner is 78%.
I'll guess descriptive.
Of course it is descriptive. Excellent. Next page. We are 95% confident. This is what we want to say, 94% confident about this. That between 74% and 82% of all students who return the money would return the money.
Inferential.
Right, we made an inferential from a statistic. We made an inference about the parameter of all students. This is the key word. All students. We are drawing a conclusion about all students. It must be an inferential statistic. Very good. Is the given measure a statistic or a parameter? Circle the correct answer. The percentage of all students on your campus, all, who own a car is 48.2%. Statistic or parameter?
Statistic.
All students. All students.
Parameter.
The entire field. Parameter. Is that clear with everyone? Everyone okay?
Yeah.
Okay. Suppose a random sample. Keywords. Random sample of 100 students is obtained. And from the sample we find blah blah. Statistic or parameter?
Statistic.
Great job. Okay. So this is just an idea of how the process of statistics works. So you have an idea of the steps that are involved here. So a researcher must determine the questions he or she wants answered. The questions must be detailed so that it identifies the population that it is to be studied. So this is basically the research objective. So this first question is nothing else but the research question or objective. If we don't have a question, we cannot start a study. Conducting research on an entire population is often difficult and expensive. We know that. So we typically look at a sample. That's the key. This step is vital to the statistical process because if the data are not collected correctly, the conclusions drawn are meaningless. So when we talked about the sample, I mentioned, and this is extremely important, if the sample is not representative of the population, whatever I conclude has zero meaning. I cannot rely on anything. Do not overlook the importance of appropriate data collection. So what is the second step after we have a research question? The second step is to collect the data. So number 2, collect data. To answer the question number, part 1. Descriptive statistics allow the researcher to obtain an overview of the data and can help determine the type of statistical methods the researcher should use. We're going to describe, analyze, of course summarize, describe, analyze, summarize. And the last one, what would be the last step? What is the last step of any statistical?
Draw a conclusion.
Yes, exactly. Inferential. We are drawing conclusions about the population that we don't have. Inferential. Inferential statistics. Draw conclusions. Excellent. Perform the inference. Okay, example 12 we can skip because I like to proceed with this, and I would like to see if you need any help with entering my Labs Plus. So we can look at that next time. These are more important. Distinguish between qualitative and quantitative. 13. Distinguish between qualitative and quantitative. Okay. So we already know a qualitative variable is. Anyone?
Did you say
Qualitative is non-numeric, right? First of all, what else? What else can we say? It's non-numeric. What can we say about that?
It's infinite.
Well, qualitative variable is the one that we discussed as being eye color. That's okay. Eye color, etc., etc. Quantitative is numerical. Quantitative can be, as we know, what did we say? The quantitative.
ordinal?
Yes.
What does the second word say?
Non-numerical, numerical, like eye color, non-numeric.
And then the one under non.
Numerical, numerical. Right? So the quantitative can be of two types, right? Discrete, and continuous. The discrete are the ones that are finite, number of children, number of cars a family has, number of homes, number of pencils. Discrete, finite. Continuous, time, weight. Because remember, they can be 1.2, 1.295, but discrete cannot be 1.295. So gender, what will you say gender is?
Continuous.
Gender, first of all, is qualitative because we cannot perform any operations. That's why we need to talk about all these things, right? So gender is qualitative.
Nominal.
Qualitative, and because we cannot order it, qualitative and nominal, yes. Temperature.
Quantitative.
Quantitative. Quantitative. Number of days during the past week that a college student studied. Very good. What about zip code? We cannot analyze it. We cannot perform any operations with it. It's basically like eye color. Qualitative. We cannot perform operations with eye color or gender or zip code. It doesn't mean anything. The results will not mean anything. Distinguish between discrete and continuous. Discrete, we already wrote what the discrete is. Finite. If you want fixed, a number that is nothing between integers. So like 1.29 is not this. It's not discrete. I can't have 1.29 pencils. Continuous can be anything. Anything else that is not finite. For example, we wrote that, weight, time, blood pressure, can be anything intermediary, anything. If you can put it between 1 and 2, like somewhere here or here or here, it's continuous. You can, if you only can say 1 or 10 or even 10 million, but fixed, then it's discrete. Otherwise, it's continuous, as long as it's quantitative. Okay. The number of heads obtained after flipping a coin 5 times. Discrete or continuous?
Discrete.
Yes, because can I have 1.239? Can I flip the coin 1.239 times? No, so it's discrete. The number of cars that arrive at the McDonald's drive-thru between this and this. Can I have 1.239 cars?
No.
So what should it be?
Discrete. Discrete.
The distance that we can travel with a full tank. Yes. Because I can have 1.239 whatever. Not in this case with a full tank, but you know what I mean. Okay, now also about quick definitions about data and qualitative data and quantitative and discrete. I think we covered this enough. Do you consider that this is pretty clear now? Or we still need to go over it?
I would like just to have the notes to just go back to.
Okay, very good. So what is the data? It's what we observe. So list of observed values. for a variable. List of observed values for a variable. What is qualitative data? Well, it's data corresponding to a qualitative variable. So notice that sometimes we refer to data or variable, but they really in the same sentence or interchangeably, but data is collected on a variable. So if the variable is qualitative, then the data will be qualitative. If the variable that we are collecting data on is quantitative, then the data will be quantitative. So this is a list of observations on a quantitative variable. So quantitative variable has qualitative variable has corresponding qualitative data. Quantitative variable has corresponding quantitative data. Sometimes they are interchangeable. Of course, discrete data corresponds to a discrete variable. So observations on a discrete variable. And finally, continuous data. Observations corresponding to a continuous variable. Corresponding to a continuous variable. Okay, so let's look at this table, and then I'd like to make sure that you can enter MyLabs Plus. So let's analyze what the table is asking us. It says identify the individuals, variables, and data. So first, individuals. See, the first column talks about country. The second column about government type of the country. The next column talks about life expectancy of the people in the country. And the last one, the population in the country. So can anyone identify the individuals that we are running the study on? Who? Excellent. Individuals. What are the variables that we collect on these individuals?
Government type, life expectancy, population.
So all these three represent variables. Very good. What is the data that we, sometimes they're called R data, is data, I'm not sure, everyone is different. So I'm going to say R. So can anyone identify the data? This is the data. That's the data itself, or R. What type of variable is the government type? Qualitative or quantitative?
Qualitative.
Qualitative, of course. So government, qualitative. Excellent. Life expectancy. Very good. Population.
Quantitative.
Now I would like one more thing to identify. The life expectancy. Is it discrete? Because we know quantitative can be discrete or continuous. Quantitative, life expectancy, excellent. It's time, it's in the years. Is it discrete or continuous?
Continuous.
Great job. Quantitative, population is quantitative, excellent. What type? We know for...
Discrete.
Very good. How come? Because I cannot have 10.395 people. Oops. That's not possible. So it's discrete. It's big, but it's not infinite, and I cannot have 10.395 people. Because I cannot have 10.395 people, it has to be discrete. Well done.